Back again at the command center of the JW Solar US in Minnesota. Thanks for watching. Guys, I'm here to give you an update. It has been 16 hours since we were off grid with this one old system. As you guys can see, the refrigerator, I can hear it running in the background. The freezer is taking a rest, and it seems like the refrigerator is just a start. As you saw on the first video, we surged up to approximately 160, 180 amps, and just the refrigerator, which is bigger, it has a fridge and a upper level, which is a freezer, a family size refrigerator, is taking zero amps. So it's not even, it's a less than an amp it's taking, so it doesn't register. So when the freezer runs, which is like I always say is the most efficient, I can see a 2 amps. Okay, but the surge, when it starts, the refrigerator takes a lot of power for a while. Both of them can pull about 7 amps, and after that it started resting at 5 amps. So now the freezer is resting on a cycling mode while the refrigerator is running is 0 amps, guys. So it looks like just the starting point is the most draw it has. Right now we are looking at a 14.2 volt, which if we do a division or calculations and trying to divide 14.2 is fluctuating 14.1, 14.2, we are sitting at approximately 7.1 volt per module. This is what I mean by 14.1 divided by 2. So guys, you see these are the modules here. So each module now is reading approximately 7.1 volt. We can try that and see according to the meter, the MERC50. So we have 7 of these, okay, 7 of these in parallel, okay, right here. And here's the black started again all the way back in there. That gives us 14 modules altogether. So let's take a test, voltage test right here. Stay tuned. Once here. So let's check voltages here and see exactly where we are at. If I can set this one up there, if you guys don't mind, and I can test one of the probes and see from here what the center tap is reading. Okay, we got this one here and get this one right here. We are reading at 3.53 volt, and we'll come back here, try back the center one, 3.530. So if we decide to read one battery is going to put right now here and there is a 7.06. So the reason why I was testing the center tap, because this is a battery as well. There are 4 batteries in the NISSAN LEAF battery module. 4 of them, 2 of them are wired in series, 2 of them are wired in series and parallel them. That's why. So if I'm taking it this way, all the way 7 right there, this is 7 modules. These are 7 modules all the way down here, and 7 modules start from there, from the black side right there all the way back there. So by doing so, putting the testing this guy right here, which I've already done, and we are gonna be reading 7 modules all the same voltage. Okay, see right there. So let's check the other one. So this will be, if we switch some gears here, so the other modules start here. You can see the black. We're done with the reds here. So this is where it series itself for the 14 batteries to be connected together. So let's try this one again. We're going to be running the negative here and test it to these guys. Send a tap right there. Look at that, 3.53, and use it right there, 3.53. And now if we're trying to tap this one to here to test the full battery to 0, so that means we are sitting at 7 volts per module right now, roughly. That was like 7.1 earlier, so it's coming to almost 7 volts per module. It's over 16 hours, approximately 17 hours now. But this guy has been so efficient. The 2019, a lot of people are talking about the 12 volts for inefficiency. So inefficient, but because the voltage is lower, I tend to use a lot of amps. They said it's not efficient, but you know, guys, the system had proved itself, because running the freezer and the fridge from yesterday, since yesterday, and all the way 18 hours or 17 hours, right, from that time up to this time, I think the system is doing pretty good for only 260 amps. Let's check it out and see. There you go, guys. It's 231 amp hours on this 7 kilowatts of power. So we're running approximately 17 hours on these batteries non-stop. Open the doors on the refrigerator, closing, and do our normal thing. Just the refrigerator and the freezer is running on this system right now. And I didn't connect the Whizbang Junior here for the system to be able to recognize or do a countdown. That's why it's flashing. It's not set up. And the battery monitor kit is not set up on this one. But I'll try to do that on my next video, to see how everything works here. We can monitor things the way it should. Live at the command center of the JW Solar USA. The batteries are doing well. Thanks for watching. And thanks to Magnum. We love you. And thanks to the Midnight Classic for being part of this, even though we don't have no sun outside. But you're awesome. And the BMK or battery monitor kit is still here showing us what's going on, because we're relying on the voltage right now. It's not like any of the state of charge or giving us readings how many amps in and out of the battery. But this is the BMK I have right here, which I'm going to be incorporating soon. I hope you're going to see those videos and subscribe and like the videos. Stay tuned. Here is the BMK, the battery monitor kit communication, which is a network cable. So this will be right here on the green. That's one of the things I like about Magnum. Everything is labeled, it's color coordinated, and you can able to, even you can read, you can follow just color coordination. You plug things where they should go. Here's a remote, it goes on the blue. Battery temperature sensor go on this one, the yellow. The green is the network. The red is for stacking, if you want to stack these inverters to make it big. So right here is the I got this one in the mail. So here is the BMK that if it's for midnight, it's gonna be battery, which is the Whizbang Junior. Is the battery monitor kit. This is the one that takes care of business, and Here where you plug in the wire, the sensing wire that goes to the shunt, and this guy right here, this wire connects to the network, which is like a RJ12. That's how you can RJ12, like a telephone cable, not Ethernet cable. Ethernet cable is a RJ45. So here is the shunt. This is just like a resistor, okay, that is just there, and one side is gonna show a 500 amps, and this guy here it's gonna be a 50 millivolt. So this side is where you connect the battery, the output of the battery here. It only goes to from the negative. So if I have to cut this wire, and this 500 amps will be here first. From here, if I decide to cut the wire right from here, and I'm gonna attach it from here, and this other side is gonna be this other piece here that goes to the loads or the inverter or the charge controller connect on the 50 millivolt. Is a Deltec. Okay. So if we have to come back here, I don't want to make this video too long, but I have to explain to you guys, for those of you who haven't done this. And this guy here, this last two spot right here, connects to the side here on the shunt. Okay, you get an orange and blue cable that attach here, orange or black, orange or blue, whatever, blue, I think so. And you tie it here. Those are the ones that gonna be reading. You have two of these is the two of these guys is the positive and negative from the battery. Okay, it's like positive that sends the power. This thing get powered. It's gonna be a green light, goes from amber and red or green. The power thing comes in here, and the sensing wires attach to this guy here. Right? Well, and the other side of the positive that goes to the positive terminal have to have an inline fuse, which is a 2 amp that is recommended. So for my application, I use a breaker, 2 amp breaker, because fuses tend to blow up all the time. And how many times you have to change fuses? But they're expensive, but not that expensive. But if you have a breaker, if you look at my my install with the Grillmeister Dave, and with my system, my 4024 PAE, and I use a breaker as well, because it's just a matter of, if it trip, then you can just flip the breaker again, so you don't have to buy fuses all the time. So you just reset the breaker. So this is the complete installation, how the system works. It's a little guy. If it was a FlexNet DC for Outback, it costs you over $300 some for the FlexNet DC, but it has its own advantages and disadvantages. But it uses the same shunt, just like the Midnight Classic or the Midnight Solar, which is the Midnight Whizbang Junior, is the cheapest one among these guys and among the FNDC for Outback. So Whizbang Junior, you can able to do a lot of stuff into it. They all can communicate, do the same thing, but it's a small device. I have it. I wish I would have brought it on the video thing. It's a small, narrow, just like thin as this corner of this bus bar, but they always do an awesome job, guys. But The video is almost long now, 14 minutes or something, and I just want to explain this to you guys. And some of you guys will say, are you going to install a Whizbang Junior, or are you going to install BMK? So for my application here, I have the advantage to use a BMK, a battery monitor kit for Magnum, or for this guy here, I can use a Whizbang Junior, either or, whatever I want to do. I can able to utilize that, and they're all gonna work. If I want to put two of them, two monitoring system, I can, and I can use the BMK for here, but because I have both monitoring system available for me to utilize. Thanks for watching. This is just the updates and throw some extra ideas for you. If you find this video helpful, please don't hesitate to subscribe or ask questions. And I hope everything makes sense or clear to you guys on the 12 volt configuration or 12 volt application. I've done 24 volts and 48 volt. I would love to do the 36 volt. We have to keep fingers crossed. Might be is the next inverter here at the command center, where we're going to be trying our first 36 volt inverter. But for the meantime, thanks for watching. Live from Minnesota, JW Sulo, USA. And we are sitting at 14, exactly 14 volt. Divided by 2 is going to be 7 volt. Pan cell right now. Bye.